So today we are beginning our factoring unit. We talked yesterday about how factors are the numbers that you multiply together to get a certain number. We also need to talk about what the word prime is. What does the word prime mean?
Even numbers?
Odd. Not even. Not odd.
All right. Take another lap, man. Oh, I get it. Optimus Prime is odd.
What other numbers?
You can only be multiplied by 1.
Very good. Okay, so let's write this down since we had a hard time figuring that out. Prime means that it can only be multiplied by 1 and itself. 1 and itself. And so let's give some examples of prime numbers.
1.
Okay, 1 is neither prime nor composite.
Yeah, that's
2.
Let's start with the smallest of the prime numbers. 2 is only 1 and 2, right? 3, 5, 7,
9. By 1 and itself.
13.
11, and then you said 13, and it could go on forever. Each of these numbers can only be multiplied by 1 in itself to get that number. And so these are your prime numbers, and each one of these things that we do today has to get down to these numbers. Okay, when we factor it and we figure out what numbers multiply to that, we have to make it go as low as it can go. When we say as low as it can go, all of the numbers need to be prime. Okay, so let's look at number 12.
Yes, I understand.
What are the numbers that will multiply to 12?
Does 1
Two
count on
numbers.
this?
Two numbers.
3 and 4.
3 and 4. Okay. So is the number 3 a prime number?
Yes.
Yes. We're going to bring it down because the number 4 is not a prime number.
Oh, it's this thing?
So 4 can be broken down to what?
2 times 2.
2 times 2. You may recall that this is a factor tree.
Oh.
This is called prime factorization because each of the numbers at the very end of the tree are all prime numbers. Notice how I marked off that second row there. The first row is the 12. The second row is 3 times 4. We're done with that one because the 4 is composite. It's a number that can also be broken down even further to more prime numbers.
Did you want us to mark out 3 times 4?
It's just a 3. We just dropped the 3 down because it's prime. You just keep, once you find a prime number, you just keep dropping it down until you've got all prime numbers across the board. Okay? So these are the numbers that are prime that will multiply to 12. All right, let's go on to 210.
Oh,
3 and 70.
I'm sorry?
3 and 70.
Okay, so 3 and 70 give you 210. Is 3 prime?
Yes.
Is 70 prime?
No.
No. So we do 3 here,
No,
3 and 7 and
and then I heard 7 and 10. Okay, hold on just a second. 3 times 70 is no longer possible.
What's up, girlfriend?
Then the 10 can be broken. So that means that we're going to bring the 3 down
And the 7.
and the 7 down. And then we put 2 times 5 here, and we're no longer in need of that line. So our prime factors that multiply to 210 would be 3 times 7 times 2 times 5. Okay? Questions on how we do the prime factorization of just a plain number? All right, now what we need to do is do the prime factorization of a monomial. Remember, a monomial can include letters and exponents. Okay? So let's go ahead and break down the 15 just like we did the others. 3 times 5. Now let's break down the a to the third. What does that 3 tell us to write down for the a?
3.
squared.
A to the third power says write down the a
8 times
3 times. So a times a times a.
Pointless.
B squared tells us to write down the b
2 times.
2 times,
You can just write B squared.
as we're writing b times b. And so once we get here, this is the prime factorization because these are all the prime numbers and letters for 15a to the third b squared.
So are we going to have something like a to the 21st?
Yeah, we won't have any like that, but it's possible to have that. And once you've practiced this a lot, you'll start to learn how to figure them out without having to write them out as many times. All right, so on letter B, you'll notice you have a negative 45. When you have a negative number, the very first factor that you want to factor out is a negative 1. A negative 1 times 45. Well, 45 is not prime, so we're going to bring down the negative 1, and we're going to break down the 45. 9 times 5. All right, not all of these are prime, so we're going to go ahead and break down. We'll bring down the negative 1, and we'll break down the 9. And we brought down the 5. Negative 1 times 45.
Wow.
All right, so shh. So how many times will I write down the X? How many times will I write down the Y? Twice. So these are all the prime factors that will multiply to negative 45xy squared. All right, let's look at letter C. The 7 is already prime. So we can just write down 1 times 7 so we can get some factors in there. And then how many R's will we write down?
2.
And S's?
5.
And T's. That is the prime factorization of 7R squared S to the 5th T. Any questions on just how to get the factor tree for each one?
What will this be used for?
Well, you're getting ready to see. Okay? All right, so now we are going to fill in this little sentence here. It says the greatest common factor or GCF is what is otherwise known as greatest common factor of 2 or more integers is the product of the factors that are common to the integers. So now what we're going to do is take what we did and we'll do that on 2 or more items and see what do they have in common. So let's go ahead and get started on that. You'll notice on letter A that you have 2 numbers, and we want to find the greatest common factor of those 2 numbers. So the first thing we're going to do is write down the factors of 15. 3 times 5. Are those prime? Yes. So we're done with that one. I'm going to just put a mark to separate the 2 numbers that we have there. And now we do 35. 5 times 7. All right. Are those prime?
Yes.
So now what we're going to do is we are going to find the greatest common factor of these 2 numbers. So look at both columns and see what do they have in common.
5.
They have a 5 in common. So I'm going to circle the 5. Greatest common factor then is 5. All right, the next one has 3 numbers. So that means we need to factor 3 numbers and then see what do they all 3 have in common. So we're going to do the 12 first.
3 and 4.
3 times 4. The 3 is prime, but the 4 is not, so we'll drop the 3 down. 4 is 2 times 2. That's as far as that one will go.
You're right.
Now let's do 42.
6 and 7.
6 times 7. The 7 is prime, but the 6 is not. The 6 can be broken to 2 and 3, and we'll just drop down the 7. Now is it prime?
See.
So now we're going to do 96.
8 times 9.
12.
8 times 12 is 96.
Yes.
You could have used 6 times 16. You could have used 2 times 48. Either one, but you still have to keep going because both of those are composite. What is 8 break down to? 2 times 4, 4 times 2. And how about the 12?
3 and 4.
3 times 4. All right, so now are all 4 of those numbers prime?
No, you can split the 4s.
You have to split the 4s. So we'll bring down the 2. This 4 multiplies to 2 times 2. bring down the 3, and then this 4 breaks down to 2 times 2. Now are they all prime? Yes. So now we need to go ahead and look at all 3 of them. It has to be in all 3. So do they each have a 3? Yes. So I'm going to circle all 3, and when I finish circling, I'm going to put a 3 in the greatest common factor spot. Do they all have a 2? Yes. So I'm going to circle the 2 in each one, and then I'm going to put that in the greatest common factor spot. Do they each have another 2? All 3 of them have another 2? No. So we're done with the numbers. What we now need to just do is simplify this. The greatest common factor of these 3 numbers would be a 6. Questions?
Wait, so you multiply it by 2?
Uh-huh.
Yes.
Questions?
No, that's
What?
All right, so then now let's go on to doing the same thing but with numbers and letters with exponents. So we're starting out with 27a squared b. 27 can be broken to
9 times.
3 times 9. The 3 is prime, but the 9 is not, so we'll do 3 times 3 for that one. Now let's break down the letters. How many A's will I write down?
2.
How many B's?
1.
And I'm just going to put them underneath so that there's a little bit more space to see everything. All right, now we'll do the 15ab squared c. 15 is broken to 3 times 5. How many A's?
1.
How many B's?
2.
And how many C's?
1.
1. So now is the time, since we've broken each one of them down, now is the time to decide what do they have in common. They each have a what number?
3.
A 3. Do they have any more 3's in common? No. So 3 is the only number that is our greatest common factor. Now we look at the letters. Do they each have an A? Yes. So we write that in the greatest common factor. Do they each have another A? No. So we move on to the B's. Do they each have a B? Yes. So then we write down the letter B. So our greatest common factor for this one is 3AB. Questions?
None.
Okay, look at B. How does negative 39 get broken?
Negative 1 times
Good. Remember, you need to put a negative 1 first. Then we'll bring down the negative 1. And how does the 39 get broken?
Is it just prime?
Nope.
Oh, 3 times 13.
3 times 13. Very good. Now, are they prime? Yes. How many X's?
2.
How many Y's? Okay, now we're doing the negative 26.
Negative 1 times 26.
Negative 1 times 26. Bring down the negative 1, and then 26 gets broken to
2 times 13.
2 times 13. Is that as low as it can go? Yes. Let's do the letters. How many X's?
4.
And Y's?
4.
Okay, now that we've broken them down, it's time to decide what they have in common. All right, so I see the negative 1. Heard that too. Negative 1. And so we'll put that in our greatest common factor. What else do they have in common?
13.
A 13. So that also goes in the greatest common factor. Do they have an X? Do they have another X?
No.
No. Do they have a Y?
Yes.
Do they have another Y?
Yes.
Do they have another Y?
Yes.
So each time we find something that they have in common, we write it down over here. Then we simplify that. So then for the number, we have a negative 1 and a 13. That's a negative 13. We have one X. And how would we write Y?
Y cubed.
Y cubed. Good. So this is the greatest common factor for those two monomials. All right, last one. The sides of a triangle are 12wz squared, 8wz, and 16w squared z.
Can you have to draw the triangle?
Find the greatest common factor of the three sides. All right, so we're going to start out with 12wz squared. How does 12 get broken?
2 times 6.
2 times 6. 2 is prime, 6 is not, so we'll break down the 6. 2 times 3. How many w's?
1,
And z's?
2.
Can we use these like that sound like twos? Or
Yes. All right, so how about the 8?
4 times 2.
The 2 is prime, but the 4 is not. So we break down the 4 with a 2 and a 2. 1w, 1z. All right, so now we've got a 16.
4 times 4.
4 times 4. Neither of those is prime, so we will break both of them down. How many w's?
1.
How many z's? All right. So after we break them all down is when we decide what do they have in common. Remember, when you find something, you write it over here in the GCF. Do they each have a 2? Yes. So we circle the 2's and we write a 2. Do they have another 2?
Nope.
Yes. So we circle the 2 and we add another 2 there. Do they have a 3?
No.
No, because they would all have to have a 3. So then now we look at the letters. Do they each have a W?
Yes.
So we put a W in the answer. And do they each have a Z?
Yes.
So we put a Z in the answer. Do they have another Z? No. So we're done now. We just have to simplify. So it would be 4WZ.
Coach.